All right, hello. We are Team Model Behavior, and our project is on a small business florist and gift shop. Chad, Corey, Anthony, Tonito, and myself, Sierra, will be taking you through a day-to-day processes as a local florist and gift shop. Our company, Easy Flowers, is located in Napa, California, and we sell a wide range of locally grown flowers such as tulips, roses, lilies, and many more. We specialize in preparing custom bouquets and gift arrangements. We offer delivery services through USPS, Instacart, DoorDash, and many online delivery services. We believe in preparing and selling quality flowers for you and your loved ones. Even if we don't carry a particular flower, we will be happy to order it for you. We offer discounts to seniors and military. As for our operations, they are as follows. We order inventory such as flowers which are locally grown and gifts from a vendor. We then care for the flowers and stock items on shelves while tracking and maintaining inventory. We take customer orders online or in person. We will then transact payment via cash or card, and then we will prepare bouquets and quality packaging. And finally, delivered to our customers via delivery services or in-store pickup.
We were able to identify 4 tables for our database system. Tables are customer table, customer ID is the primary key, first name, last name, phone number are other attributes of the customer table. Another table is a line item table, order ID, flower ID, inventory quantity, price per unit, final price. Another table that we created for the database is a flower table. Flower table would include 4 attributes. Flower ID is the primary key, flower type, inventory quantity, price per unit. And the last table that we created for our database was an order table. This one is got a little bit more information in it. Got an order ID, order date, payment type of customers paying for with a credit card or check, something like that. Subtotal, tax, final price, and also the customer ID would be included in the order table.
So I'll be reading Database Management Plan. So for the data description, the data we'll be collecting is information about our customers, inventory, and transactions. This includes customers' names and information, orders, transactions, inventory count, inventory type, prices, dates, as well as shipping information. Responsibility of the database will be handled by the owner as well as employees. Anyone who is inputting information into our database is instructed to enter everything correctly to protect data integrity. Designated archive. The database will be stored locally with the end-of-day cloud backups being uploaded to AWS servers. From slide number 9, Database Management Plan, Access and Sharing. Easy Flowers database will only be accessed by employees, the owner, and anyone who has express permission from the owner. No one can share. Certain exceptions are based on circumstances, manipulate, or otherwise change the data in the database unless given permission from the owner. The only public use data files will be information generated on a receipt or invoice. All other files will be restricted use data. Selection and retention. All information will be held for 1 year from the date entered. After, it will automatically be deleted from the database. This is done to prevent too much information being stored locally and to help prevent stress on the system. Metadata. All metadata generated will share the same rules and stipulations as the other date. Most metadata would be descriptive metadata, flower types, flower price, etc., and administrative metadata, order ID, quantity, and etc. Intellectual property rights. Easy Flowers and the constituents own all copyrights and data we generate. Ethics and privacy. As stated above, no information outside of receipts will be shared with anyone outside of the company. Some exceptions do apply for business and marketing use. These will be case by case deal.
Alright, right now I'm going to be talking about the functional dependencies for our database. So we have them listed as flower, order, and final price. Functional dependencies are going to be when the attributes kind of depend on each other, and that's why you can see that flower ID is dependent on the type of flower. Order is going to be dependent on the customer ID and the order date, and final price is going to be depending on the price per unit, the subtotal, and the text, because all of these attributes are going to be working together to get towards this other attribute, which is final price. And that's going to be our functional dependencies. Next, we have our normalized tables, and those are customer, order, flower, and price. For customer, we have customer ID, first name, last name, phone number, and customer ID is our primary key. That's also our primary key in the order table that has customer ID, order ID, and order date. Next, under normalized tables, we have flower. That has flower ID as the primary key, flower type, inventory quantity, and price per unit. And then finally, we have price, and that is going to have payment type, subtotal, tax, and final price. Normalized tables was a way for us to kind of consolidate our data and break it down so it's more organized and a lot more easier for the company itself to read. It also just looks better for the database. For as far as our flow chart, here is we have pretty much to start the whole customer order experience. They're going to be browsing the store, seeing what flowers we have out on the shop. They're going to make their selection. That's going to eventually generate their order details, what's going to show what kind of flowers they bought, the quantity, and eventually they are going to be checking out after that, and then they'll be getting a receipt with that purchase as well, and that's listed here in our flowchart. So here's some of our data requirements. So for the basics for our company, we just need your name, your first and last name, what kind of flowers you're going to be getting, how many, and then of course we need to collect some form of payment, and that's just what the data requirements are. Kind of showing that what does our store need to complete the order, and that's what they need. Here we have our ERD, and this is going to be showing our relationships between our tables. So we have customers, orders, flower ID, and line item. As you can see, all the primary keys are underlined and bolded, and then the attributes are listed under them. And then we have our connections, whether that's many-to-many, whether it's the crow's feet symbol or the train track symbol. Our ERD lists all of our relationships and shows that for our tables.
I will be presenting our sample data. We have 4 different tables within our flower shop dataset. The first one is the customer table. As you can see, we have columns for customer ID, first name, last name, and phone number. Each customer has their own customer ID, which is a 5-digit number, and it helps to track orders. The next table is line item. This table has 5 different columns for order ID, flower ID, inventory quantity, price per unit, and final price. Order ID is the primary key. Flower ID represents each one of the 15 flowers available, and the inventory provides information on how many flowers we have in stock. Next is the flower table. This table has columns for flower ID, flower type, price per unit, and inventory quantity. This table is useful for showing all flowers available for purchase. Each flower is represented by a particular number, which is their ID, their price per unit, and how many of that type of flower we have in stock. The last table is the order table, which has 7 different columns. They are order ID, customer ID, order date, payment type, subtotal, tax, and final price. Each individual order has its own ID number, and order ID is the primary key. The customer ID is included to locate a particular transaction. The order date provides the date of the order and payment type, whether it be cash or credit. The subtotal tax, and the total price of each transaction. I will create some sample queries. The first one is from the customer table, where I will be selecting the columns of the first name, last name, and phone number. By entering in the phone number, I will be able to bring up the first and last name of that particular customer. The second query is looking for customer IDs greater than 17688 and less than 31114. Perhaps you had to search for a particular customer and you couldn't remember the customer ID exactly, but you knew that they were between these numbers. This would be a helpful query to use. The third query is searching for final prices that were greater than 100. Perhaps you wanted to know which flowers were selling the most and making the most profit. This would be a great query to use. The last query is utilizing the Count As and Group By feature to count how many store transactions happened in the last 3 days. This puts the sum of orders for that day in the order ID. For example, on the 10th of May, there were about 5 transactions. The 11th, there was 7 transactions. And on the next day, on the 12th, there were 6. This helps keep track of the store's total sales for those days. That will conclude our presentation. Thank you very much for watching.